parallel circuits. Now, when we were doing parallel and series circuits, Jordan, what did you find that was different between the two of them?
Sorry, could you say that again?
Yes, sir. Now that you've read parallel circuits, what have you figured out is the difference between series and parallel circuits?
Alrighty. Parallel to me seems like it has more connections, like it's able to run more currents to me than a series.
And what happens with a parallel circuit is, remember with the series, you had a battery and then you had a light bulb, a resistance, a light bulb, and so on, and it all formed one loop. As
Right.
today, a series, if you take one of those light bulbs and it's blown, what happens to the rest of the light bulbs? They don't work. Kind of like Christmas tree lights. If you bought a Christmas tree lights and you have one bulb that's broke, you don't know which one it is. And let me tell you, it's a pain to try to figure out which one is not working. So, you have to, because what happens is all the lights go out. So then you got to keep testing each one until you find the one that's not working. The great thing about parallel is that you have a battery, then you have a wire, and then your lights are this way, or it could be in a different way, but mostly it's parallel going up and down. And then one will work, all three will work, or two will work. It doesn't matter. You're going to have the same thing going on there, where it's a little bit different with the math. So what I'm going to do is I'm going to put on my overhead projector. I'm going to kind of go over some information. Me and Miss Leslie Hewitt has been working on my overhead projector and the volume. So we're going to see if it works. And if it doesn't, I'm going to do just like what I did yesterday. I'm going to periodically stop where I'm doing, come back, turn my camera back on, and make sure that you understand what we're doing. So put this in. And so if you look here, here's my notes that I took today. And so when you're talking about a parallel circuit, you have your battery here, and then you have your positive and negative wires, but they branch off to where your resistors or your light bulbs are, okay? So when we have these, when one comes out, say this one doesn't work, guess what? The other three will, okay? Unlike the series circuit that we had yesterday, when one stops working, the whole thing stops working. So when we're talking about that, resistors are parallel and have the same potential difference across them. Voltage is the same, but the current is not. So this is very important. If you do not have that in your notes, please make sure you put that in your notes, that the voltage is the same, but the current is not. So when we are going through, and remember how we did yesterday when we were looking for the current and the resistance and things like that, we had certain math. Well, today we're going to have something different. So when we're talking about it, we're still using Ohm's law, the change in voltage, and then you have your current times your resistance. But this time we're going to do something a little bit different. The first thing that I want to make sure that you have in your notes is that they have this beautiful data table here. This, and I know mine's not beautiful, but on the book it is, where it gives you the schematics of what a series and a parallel circuit is. It also gives you how you do current. It also gives you how to do the potential difference. And as you can tell, they're different. And then the equivalent resistance, as you can tell, is majorly different. Because now what we're going to have to do is we're going to have to put these in fractions. And the reason why we have to do them fractions, because when we go through there, it's going to have to be the reciprocal of the sum of the resistors. So questions so far? I'm gathering everybody's good. So I'm going to go ahead and plug it back in. And now what I'm going to do is I'm going to do the math. Now, I'm going to plug this in, and I'm going to ask one of you. I'm going to ask Grant. Grant, if you would please do me a favor and get on and say a word or two so I can see if this thing is working with this on.
Testing, testing, testing. 1, 2, 3. Can you?
And that is no. It's still not working. Thank you, Grant. I can see your little thing going, but it didn't work again. But that's okay. Because I'm going to set up 2 computers tomorrow, and we're going to figure this out. So the first thing I want to do is I want to go over the practice problem that you have in the textbook. So in the practice problem that you had in your textbook, and I am right now on page 644, and what we have here is we have a battery, and this is going to be in a series of lights, as you can tell. You have 7, you have 5, you have 4, and you have 2 ohms that are in a parallel circuit. So what happens is the bulb is connected to this side of the battery, which goes all the way down, and then this one goes all the way back down to here, but then they break off also. So I really like how they diagram this here, where they have the 9-volt here, and then what they decided is to put them staggerly. I did not do that, but this was even better. So there's your 7, your 5, your 4, and your 2 light bulb. And there's your diagram. Can I say, using a diagram is always a good thing so you can get your mindset on what's going on. So after that, what you do is you go through and you have to find your resistance equivalent. To do that, you have to put them in fractions. So you're going to do 1 over 2.1 plus 1 over 4.1 and then 1 over 5.0 and 1 over 7.0, and you're going to add them all together. But you can't do that because it's a fraction. So since you can't do that, you have to do the reciprocal of it. So what they did is they changed the 1 over 2.0 to 0.5, 0.25, 0.20, and then 1.4. And then they added them all together, which was 1.09 over 1 ohm, which would give you 0.917 ohms. Now, does anybody have any questions about that one? Do you understand what you're doing?
Yes, ma'am.
Yes,
Fantastic. Good. Okay. As you can tell, they're kind of lengthy, so we're going to kind of go over them together. I'm going to plug this back in because obviously my camera is not going to work. So I'm going to plug this back in. Can you see my paper again?
Yes, ma'am.
I'm going to take that. I forgot I can't hear you. So yeah, I'm going to take that as a yes. So question number 1, and I'm on page 645, says a potential difference across the equivalent resistance of a sample problem on problem B equals the potential difference across the individual parallel resistors. Calculate the volume of the current in each resistance. So what I did is I went back and I took the same ones from the first problem, and my voltage is 9 volts, and then I have 2, 4, 5, and 7 is going to be my resistance. And then I want to just go and find out what the potential, I want to calculate the value of the current in each resistor. Sorry. So since I'm looking for current, only thing I'm going to do is I'm going to take my change in my voltage, which is my battery, dividing it by my first resistance. That gives me 4.5 amps. Number 2, I took my voltage and divided it by my resistance, and I got 2.2. Third one, I took my voltage and divided it by my resistance, which is 1.8. And then the fourth one, I took my voltage by my resistance, and I got 1.3A. Does anybody have questions about number one problem?
Why, that's exactly what I got.
Well, good, Grant. I'm glad,
Yay.
because I was kind of worried about my math because I was trying to do it really quick. So I wanted to make sure. All right. Are we all ready for number two? Okay. Number two is the shorter one, 2. 3 is the large one. 2 says a length of wire is cut into 5 equal pieces. The 5 pieces is then connected parallel with the resulting resistance of 2 ohms. What is the resistance of the original length of wire before you cut it? So the only thing we have to do here is we say, all right, well, first of all, let's figure out parallel first, and then let's figure out series. To be able to do your parallel, you're going to take your 1 over your resistance plus 1 over your resistance. 1, 2, 3, 4, and 5 resistance, right? So that would be 5 over R. So based on that, we would take 5 and we would multiply it by 2 ohms, which we would get 10 ohms. But a series is a little different. A series, remember, has to be all 5 of them. So 5 times 2 is 10. So you do 5 times 10, which would be 50. So the parallel one would be 10 ohms, and our series would be 50 ohms. Questions about number two?
Could I see that work again? I think I might have something else.
I will show that to you again.
Oh, I see where I messed up.
I wonder if I can connect. I'm going to try to connect on my phone to see if we can do it this way for right now. Grant, did you have a question?
I saw where I messed up. I think I forgot to add one of those. But accidentally put 4 instead of the 5.
Okay, that's fine. What I'm going to do is I'm going to try to access it on my phone too and see if I can hear you through my phone. So
Good deal.
hopefully we'll not like do a feedback, but we'll find out. Is everybody ready for God knows number 3? Did anybody do God number 3?
I'm ready as we'll ever be.
Anybody got an answer for me that you got for A and B? All right, let me show you what I got.
Is this similar to what we were doing yesterday?
Yeah, I'm
But just
doing number 3, A and B. I'm going to start with 3 first. Did that answer your question, Jordan? I'm sorry, I got off. I saw you still talking.
Oh, I was saying, is this like what we were doing yesterday? That's similar way of doing it.
It's similar, but it's different. So, let's see. Yes. Yes. It's very scary. Okay, so we're going to try number 3. I have feedback, so it's driving me crazy. Let's see if I can. All right, so for number 3, it says a 4.0 resistor and 8.0 resistor and a 12.0 resistor are connected to it in a parallel across a battery. So the first thing I did is I said, all right. So it says that we have a 4.0 resistor. It says we have an 8.0 resistor, and it says that we have a 12 ohm resistor, and it has a 24 volt battery. So I'm just going to go ahead and draw mine because I didn't do that because I had, obviously I forgot. So we have a 4.0 ohm, we have an 8.0 ohm, and a 12.0 ohm. And our battery this time is 24 volts, okay? So A says, what is the equivalent resistance of a circuit and the total power displaced by the resistor in the circuit? So to be able to do that, the first thing, yeah, that's me. So the first thing that you want to do is you want to go through and you want to take and find out what your resistance equivalent is. Since this is a parallel circuit, you will do it in fraction again, which is your 1 over 4.0 plus 1.8 plus your 1.12. Reciprocal of that, which should give you 0.45 over 1 ohm, negative 1. Now, this one's a little bit different. So let me unplug for just a second. All right. So then I think I can do it anyway. So where is your question on the first part? Did everybody get the 0.45 or did you get a different number? What I got was 2.2 ohms is my answer. Is that what y'all got?
Wait, what answer did you get, Miss Holmes?
I got 2.2 ohms.
Okay, that's what I got too.
Everybody else?
Yep.
Mary Sloan has left the meeting because Mary Sloan can't hear herself. Okay, so let's look at the second part, which is number 2 part of it. And I promise you, I'm going to try this overhead projector thing fixed tomorrow so we can talk without me having to unplug every 5 seconds. So let's look at number B. So for number B, it says, what is the current in each resistor? So what you're just going to do is you're just looking for current, just like you did before on everything else. So you're going to say current 1 is your voltage divided by your resistance 1. Well, I have 24 volt. And I have my resistance as 4.0, which is 6.0 amps. My current for 2 is going to be 3.0 amps. And my current for 3 is 2.0 amps. I think the only thing that was different that maybe kind of get a little bit tricky was just this one part here to find out what your resistance average is. But all right. Questions for today?
What was that last answer you got?
The last answer I got was 2.0 amps.
All right.
So what I would like you to do now is to get on your Google Classroom, go back to your PhET lab that we were doing yesterday. So I'm going to present. And what we're going to do today is the same thing that we did yesterday, except this time we're going to go through and we're going to try to draw these parallel circuits instead of the series circuits. So if you go into yesterday's classwork with building circuits, go down to your PhET one. Excuse me, we're going to use it one more time today, and then tomorrow we're going to be using a different interactive. Go to your lab again. And so this time what you're going to do is you're going to try to create, the first one that I want you to create is the one on page 644, the sample problem. I want you to draw it on yours, and I'm going to draw it on mine. And then I'm going to have y'all share what y'all have, and then I'll share what I have. First thing you want to make sure you do is you got to change your voltage of your battery. Make sure you change that because it has to be a 9 volt, which mine is. so far? When you get done, if you'd let me know you got done.
Ah, finished.
Wow.
Yes.
Mastermind.
That looks cool.
All right, Grant, let me see yours since you're first one approved that's done.
Hot dog.
I had to go get a drink though, so maybe that's my problem.
Let's see. Let's see. I remember how to share my screen because I did it yesterday. Let's see how I did it.
You go where it says present now on the bottom,
Mm-hmm.
and you
Oh.
pull that up, and then you hit your screen.
Haha. Tab.
I caused a fire on mine.
Oh, here comes Grant.
Aha.
What the heck are you doing, Grant?
Which one are we on?
We're on the practice problem.
On 44? 644?
644. Yeah.
Here it is.
Wow. Okay.
Aha.
That's
Yeah.
unusual, but yeah, I like that. Grant, do you see the schematic where it has the different lines going to across?
Yes.
Okay. Does yours have lines that go from one battery to another and
They
across?
are they're connected. See the picture at the tip top?
Okay. Can I tell you that no, that's not right.
Rats.
Because this is the thing. If you put a switch on there, guess what's going to happen? They're all going to either come on or they're all going to be going off. And it will not independently do one and then the other. So go ahead. Add you a switch, please, sir. Oh, you're moving stuff now. So keep it like this. Add you a switch. Okay. Now put you some wires to it. There you go. Now you need. Oh, okay. Wow.
There you go.
Yeah.
Ah. Bing, 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 bing. This is fun. I'm enjoying this.
All right, Grant, stop sharing. Just stop sharing. Stop sharing. All right. Anybody else got one done?
Well, I don't know where I went wrong, but mine caught on fire.
All right, so open yours up, share yours with us, and let's see what you got.
Alrighty, so I'm about to do mine here on my phone. So it's not connected right now, but
yeah, but the problem that you have is you have a series.
that's true. I do have a series on it.
Mm-hmm.
Okay.
So Yep. It's on fire because you have too many light bulbs in one little bitty line.
Yes.
All right, so go on back on it again. Stop sharing. Go back on it again and have it separate. You need to have, just like the book has, where you have two lines and then you have your bulbs going that way. And they have their own separate path. So what's going to happen is the battery is going to take the wire and it's going to go all the way around. So you're going to draw a wire going all the way around first and then make connective lines in between with your light bulbs.
Alrighty.
All right, Abby, you want to share yours, please?
I'm still working on it.
That's fine. How about you, Bailey?
I don't know how to make my light bulbs come on.
You don't know how to make your light bulbs do what?
Come on, here's what I got. Hold on, that's me.
Hey, baby. All right, so now what you need to do is you need to put okay. All right, so you're only using one battery.
Okay, I thought so, but I couldn't make my lights come on.
Yep. And the battery so one goes on the front and one goes on the back. So take that one delete that one. And then take one of your lines that connect to the both of them and put it on the other end. Don't add another. You don't have to add another one.
Okay, so I'm connecting one of these to the end.
Yes. So take one of those and put one on one side and one on the other. There you go. Perfect.
That's what I got.
Beautiful. Bailey's the overachiever today. Now, Grant, did you see the difference between yours and hers?
I think I have it.
Okay, let me see. Share.
Uh-huh. Let's see if it's coming up.
Yes.
Aha!
Yay! Good job, Grant. That is beautiful. Now, do me a favor. Cut one of your wires.
Okay, just one.
But not on the end. Nope.
Oh, nope.
Not the one on the end. There you go. Now, cut one where your lights are. So just
Okay.
do one right there. Cut it.
There we go.
Do you see how the other two are still lit?
Uh-huh.
This one is not.
Gotcha.
That's what's so great about a parallel circuit.
Nice.
If you did that, it wouldn't work at all. Oh, that is just beautiful, Grant.
Yee-hee.
You are a master. All right, Jordan, it's your turn.
I'm still getting there.
Okay, well, the only thing I'm going to make you do today is if you would please make sure you do the example that's on page 644, which, like y'all, Bailey and Grant have successfully done already. Make sure you take a snippet of it to show that you have it working. And then also, I would like you to draw one other one. Let me see which one it is that has it. I would like you to do number 3, if you would, for me, please, because that one actually has the light bulb the battery is a 24 volt. And I want you to practice that today. Make sure that you take a picture of it to show me that you've changed it to 24 volts. Use the amp meter, if you don't mind, on where you can show me the voltage and how it's changing in each one of those so that you can prove what we decided today is correct. Does anybody have any questions?
All good.
Okay, so what I'm going to do is I'm going to cut you loose. It's 2:30. I'm trying to be the respecter of time for 30 minutes to hold you. I would like you to practice at least doing those 2 drawings for me today on this, on the PhET lab. We're going to do a different one tomorrow because I want to include breadboards in. Does everybody know what a breadboard is?
I don't.
Neither do I.
I only know the one for cutting bread. That's it.
A breadboard is It's kind of looks like a board. It kind of looks like a piece of wood, except it's made out of plastic. And what it has is it has a positive and negative, kind of like wires, but you don't really necessarily use the wires. And we'll talk about it a little bit tomorrow. But if you have a moment to research what a breadboard is, almost every electronics that you use a breadboard. Anything that you want to do electronically, as far as lighting things up, and also running we use the breadboards for our robots that we have. We also use breadboards in engineering. And so we're going to kind of expose you just a little bit to breadboards tomorrow, not a lot. And then we're going to continue on the path that we're going tomorrow. And believe it or not, it is Wednesday. Super excited. So I have marked you all here, and I will try to have this put up for everybody if you want to come back to look at the math again. But I think we're doing good. Grant, do you have a question?
All good. Yes,
All
ma'am.
right, sir. Good. You can go. Thank you very
All
much.
right. Have a fantastic day.
I will. You too, baby. Bailey, do you have any questions?
No, ma'am, I'm good.
All right, baby. You're good to go?
Have a good day.
I will. Abby, do you have any questions, baby?
No, man, but I'm still trying to get my light bulbs to turn on in this thing.
Okay. Well, hold on a minute. Jordan, do you have any questions?
I'm all good. I'll be getting there shortly.
All right, sir. That's good. I'll see you later. And Abby, if you'll share your screen with me.
This one? Can you see it?
Okay. Yes, ma'am. So here's the problem. Do you see that where you have your hand there? Yep. Connected
Right
to
here?
the side of the battery. And you're on fire.
Yeah. I did that already.
Okay. It's fine. You can be on fire. It's not going to hurt it. So why don't you go in here and take one of the light bulbs out? And then cut those two lines out. Yep. Just delete those wires. All right. Now, what I want you to do is I want you to, nope, don't connect that. Just go to the very end and connect it to the back again of the battery. So the wire you have on the bottom. There you go. Pull it on over and connect it there. You're still on fire. Let's see what we're doing. Do me a favor. Disconnect it again. And go ahead and flip your battery around. Rotate it. Hey, Hayden, how are you, baby?
Good.
I'm still on fire.
You are still on fire, girl. Got something. All right, do me a favor. Take the next light bulb out. Go ahead and delete that one. And the wires. Okay. Yep, you're still on fire still. All right, take the last light bulb you got left. All right, now connect it. See if you're on fire still. Wow. Okay. Interesting. All right. Off again. Let's see what you got as far as your voltage is on your battery. So click your battery twice. You got a 9 volt. All right. Do you see where it turns the battery around? Try that. Hit that button on the left-hand side. All right. Connect again. Girl. Okay. Let's do this. Now let's go ahead and let's delete some of these wires. You've got way too many. Okay. Connect this one over there by your battery. There you go. Perfect. Grab that one and pull it on over. You're still
Make it square, Abby. Try to make it square. the battery in the middle, see what it does.
I have
like,
never
right here in the
seen anybody catch theirs on fire as much as you. You're a great girl. You are something.
right there.
Yeah, delete
All right,
that.
and then just
Oh,
no, like it box it off.
yeah, well, it doesn't matter. She's gonna be on fire no matter what. She is on fire no matter.
She got a bad battery.
You got a bad battery. I don't know, Abby. You've got me stumped on that one, girl.
How am I supposed to turn it in?
Well, it's okay. I'm marking you down. All right. I'm
Okay.
marking you down as successful. But delete it all and try one more time. And if it doesn't work, then just give me a picture of it being on fire.
Okay.
Hayden, how are you, baby?
Good.
We're meeting at 2:00 now.
Instead of 2:30, that's why everybody's gone.
That's why everybody's gone. Yes, sir. I videotaped this one and yesterday's, and I'm going to put them up for you in the there. Does that sound okay with you today? It's
Yes,
my
ma'am.
because I didn't. I thought I put it in it. I
You
might.
did. I just looked at it and it said 2:00.
Yeah.
Sorry.
It's okay. We're all good. You're here. That's all that matters, and you get to see Abby set hers on fire. So what I'm going to do is I'm going to go ahead and get off here and then stop the recording. I'm going to first of all start by putting the recording for yesterday up for you, and then I'm going to put the days up. It usually takes me about 15 to 20 minutes to put them up. Okay.
Yes, ma'am. And Abby was talking about turning it in. Like, are we supposed to make a circuit?
Yes, sir.
Link. Because I'm on the link now.
Yeah, you one from yesterday. You were supposed to make the sample problems that they had for that section, that problems that we did. You're supposed to create those. So if you look from the
Section 2.
you just have to put them in there and create them and just snip it. And today, the only thing I asked them to do was do the sample problem, and I asked them to do number 3.
All right.
All right, baby?
Yes, ma'am.
Abby, good luck, girl.
I'm gonna need it.
Much love sent to you. Hayden, thank you for coming, and I'll put this up as soon as I can. All right, baby?
Yes, ma'am. Have a good one.
I will. You too, honey.